Hello everyone, this is Manohar Reddy, Department of Cybersecurity, Institute of Aeronautical Engineering. Today I am going to explain you the concept of encapsulating security payload, how it provides the service in IP security services. So IP secure encapsulating security payload. So to handle privacy as well as authentication, the IP secure uses an encapsulating security payload, which is more complex than an authentication header. So to handle privacy, the main purpose is what? To providing the privacy and security for the authentication. For authentication, IP security uses encapsulating security payload. IP security uses encapsulating security payload. So we already know that IP security is a service which is offered in the transport layer security, about the transport layer security. So IP security is authentication header plus encapsulating security payload plus internet key exchange. And this IP secure is provided service in the internet layer or network layer. So how the ESP encapsulating security payload gives the security, and it is a complex than authenticated header. So how it identifies. So generally a value of 50 in the protocol field of the datagram informs a receiver that the datagram carries ESP. So this is the initial header of IPv4. So this is the initial header of IPv4, which is a datagram, which contains what? IPv4 header, which contains what? A TCP header, and which contains a TCP data. So this is a normal IPv4 data format. But we are saying that what? The encapsulating security payload is for authentication as well as privacy purpose. So now the protocol format is being multiplied with this ESP header and ESP trailer and ESP authentication. So these three fields, ESP header field, ESP trailer field, and the ESP authenticated field, three fields are extra added in this datagram. The same datagram using IP secure encapsulating security payload. The same protocol, the same format, which is the above datagram, is using with the IP secure encapsulating security payload. So what it contains? So with this, up to this TCP header, TCP data, ESP trailer, the data is encrypted. Along with that, ESP header is added for authenticated purpose. So up to this ESP header to ESP trailer, in between the TCP header and TCP data. So from this ESP header to ESP trailer, it is treated as authenticated, and from TCP header to TCP data to ESP trailer, up to this it is a encrypted data. So now the ESP trailer and ESP header and ESP authentication is added in the IPv4. So as the figure shows, ESP adds three additional areas to the datagram. So the first one is what? ESP header. It immediately follows the IP header and precedes the encrypted payload. So ESP header immediately follows. This IP header and precedes the encrypted payload. The ESP trailer is encrypted along with the payload. ESP trailer is encrypted with the along payload. A variable size ESP authentication field, a variable size ESP authentication field follows the encrypted section, and here ESP uses many of the same items found in the authentication header, but rearranges their order. For example, the ESP header consists of what? 8 octets. ESP header consists of what? 8 octets that identify the security parameters index, which is showing here, which identifies the security parameters index and a sequence number So this is the 32-bit length of ESP header format. And in this format, what the security parameters index SPI is 0 to 31. That is nothing but 32 bits. And similarly, the sequence numbers also from 0 to 31. That is also 32-bit length. And the ESP trailer consists of optional padding. So one is what? Optional padding. And the second one is padding length field. And third one is what? Pad length. And next header field, that is followed by a variable amount of authentication data. That is followed by what? Variable amount of authentication data. So here, this is the ESP trailer format, which contains 32-bit length, and this first one is what? Optional padding. Which is padding length field, that is pad length, which is optional padding, 0 to 255 octets of padding. So that is padding indicates that what? 16-bit length. The next pad length, so which is padding. So first one is padding, which is 16-bit length. The next pad length, which is 8-bit field. The next header field is also 8-bit field. And the ESP authentication data is 32-bit field. So from there, padding is optional. So from the ESP trailer format, the padding is optional. It may be present for 3 reasons. It is optional, but it presents for 3 reasons. What? First, some decryption algorithms requires zeros following an encrypted message. And the second one is what? Note that the next header field that shown right justified within octet field. The alignment is important because IP secure requires the authentication data that follows the trailer to be aligned at the start of 4-octet boundary. That trailer to be aligned at the start of 4-octet boundary. Thus, padding may need to be ensure alignment. So third, some sites may choose to add random amounts of padding. Add random amounts of padding to each datagram. So some of the sites are having a random amount of padding is going to be done. So for each datagram. So use droppers at intermediate points Eavesdroppers the eavesdroppers are nothing but data leakages. The data leakages at intermediate points along the path cannot use the size of datagram to guess its purpose. They are not giving a chance to find that path. And here ESP without authentication and ESP with authentication. So we already said that what ESP contains what ESP header, ESP trailer along with the ESP authentication. So here this is the ESP without authentication, so that it says that only two fields it have. What is that? One is ESP header and the second one is ESP trailer. So from this, what it contains, the fields, ESP header contains those two fields, security parameters index field and sequence number field. One is what? Security parameters index field, and the second one is sequence number field. So those two are ESP header. But in the ESP trailer, it is having the padding length. The padding is optional and it is a variable, and the pad length is one type of field, and the next header is also one field. And this next header indicates that what? Next header, whether it is TCP header or either it is IP header. So that indicates that what? Encrypted payload. Here that pointed towards the encrypted payload. So this is all about the 32 bits format. And here ESP with authentication. So one is security parameters index, second one is sequence number. So these two are ESP header, and along with that ESP trailer. ESP trailer contains authentication data which is appended to this ESP trailer. So, and the ESP trailer contains what? The padding, which is optional, the next pad length, and next header, which is next header. So the next header indicates that what? Encrypted payload, which is moving towards to the next encrypted payload. And here authentication data also there. So ESP trailer with authentication. So which contains both two ESP header and ESP trailer with authentication data. So this is also 32-bit field or format. And the header fields contains what? From the diagram we said that first one is what? Security parameters index, which identifies the IDs of each and every security parameters. And the second one is what? Sequence number. Sequence number indicates that each and every security parameters index of IDs is going to be numbered with the sequence numbers. The second one is the data part. Optionally may have an IV added. Clear if necessary. It has a variable length padding. Sometimes it is needed for encryption. Sometimes the length padding is needed for encryption. And sometimes it gives a masks for encryption. And sometimes used to mask traffic flow also. The trailer part contains what? The padding length. One is padding length, and the next header field, padding length is one, and the next header. In tunnel mode it would be set to 4. In transport mode it would be set to original packet data. So how the size of original packet data contains, it would be set to original packet data. And tunnel mode would be set to 4. ESP can also have network address translation. So here NAT RP80 stands for what? network address translation, network address translation, and physical address translation, physical address translation. So one is what network ID, one is depending upon network ID, and the second one is depending upon the host ID, depending upon the host ID. If transport layer information is used, if transport layer information is used, then ESP canals, ESP have these types of problem. ESP have these types of problems. And here we can see the IP secure in ESP transport mode. So we already said that what IP secure is nothing but what the both ESP plus internet key exchange plus authentication header. So authentication header plus ESP plus IKE. So here the IP secure provide security service with ESP in tunnel mode or transport mode, in tunnel mode and transport mode. So before going to explaining this transport mode and tunnel mode, so transport mode is nothing but what delivering the services from what host to host, delivering the services what host to host or host to network, host to host or host to network. So delivering the services from both host to host or host to network. So here the transport mode which contains what IP header and a TCP header plus payload. One is what IP header and TCP header plus payload. So here which contains the IP header format. So in that IP header format contains what version of the header, version of the IP, header length, type of service, packet length, ID of the protocol, ID of the packet, flags and flag offset, flags and flag offset, and the time to leave is also filled, and a protocol which indicates that next header or previous header, and a header checksum, along with that source address and IP address, IP address. So this TCP header plus payload which contains TCP header and payload. So now this is the without ESP, this is all without ESP header, without ESP, this is the transport mode, this is only the transport mode of IP secure. But when it comes to the ESP, IP secure and ESP with the IP, so which indicates that both IP header as well as ESP header, IP header as well as ESP header. So what are the fields that extra added in this IP header under this one? Here the IP header contains what version, header length, version of the header, header length, type of service, packet length, ID of the packet, flags, then next a flag offset, time to leave, and protocol equal to ESP, and header checksum, and source IP address and destination IP address, source IP address and destination IP address. Along with this IP protocol, the additional field with the ESP is added. Additional fields with the ESP is added. So in the ESP, what are the fields contain ESP? So ESP header it contains, plus ESP trailer it contains, plus ESP authentication data, So which is option? So here this is the ESP header which contains what two fields, security parameters index and a sequence number. One is what security parameters index and the second one is what sequence number. And the ESP trailer indicates that what contain this ESP trailer which contains what padding which is optional and which is variable, along with that padding length and the next header, So next header indicates that what here, the next header indicates that ESP header. So ESP header. So that protocol indicates that to ESP. So next header indicates that what? ESP header, and this ESP header is indicated from protocol equals to ESP. Along with this ESP authentication data. So now here you can see these all the blue dotted lines. Indicates that what? Authenticated data, which is all authenticated data. So that's why we are going to studying about this ESP is for authenticated purpose as well as privacy purpose. Now this all the data is authenticated. Now this data is being transmitted to the destination. Now the data is transmitted to the destination safely and confidentially. So in this, the ESP header is inserted after the original IP header. The ESP trailer is added after the IP trailer. We already seen that in the diagram. So ESP trailers contain the padding information, and it is mostly used in host-to-host scenario. So that's why we said that what the tunnel mode, the services are delivered. The services are delivered from host to host, or host to network. So that's why the mostly used in host to host scenario, where the data and security endpoints are the same. Points. Then only it identifies and gives. And IP secure in ESP tunnel mode. So generally we said that what tunnel mode is nothing but what the services delivered from either network to network or host to network. So now how it operates in the tunnel mode. So here the original IPv4, and this is without the tunnel mode of ESP, and this is with the tunnel mode of ESP. So what it actually contains. So IPv4 datagram contains similarly like version of the IP, header length of IP, type of service, packet length, ID of the packet, flag offset, along with that time to live and protocol, header checksum, and source IP address, destination IP address. And here the TCP header plus payload. So which is what IP header format is what? IP header and TCP header and TCP data. So this is what actually the IPv4 datagram format. So here there is no ESP and there is no ESP tunnel mode. And now coming this figure, this is IPv4 header, which contains like version of the IP, header length of IP, type of service, packet length, ID, flag offset, time to live, protocol equals to ESP, header checksum, source IP address and destination IP address. Now from here the ESP header is added. And here ESP trailer is added. And here ESP authenticated data. So here ESP header contains what? SPI security parameters index and a sequence number. And similarly the IP header comes again here, and the ESP trailer contains what? Padding, pad length, and the next header, that is IP header. So which indicates from here to next header ESP header. And this ESP header is merged with the IPv4 datagram. And here ESP authentication data also there. data also there. So in the IPv4 address, IPv4 header format, the next header, IP header, after immediate effect of IP header, the ESP header presents. That's why the IP header indicates that new IP type, which is ESP, header added. So the next TCP header, the next TCP data, the next ESP trailer, ESP authenticator data. So like the way it point out towards the next header as a ESP, then next ESP indicates here, then next ESP trailer works, and the ESP authentication data works here. So this is the way the tunnel mode operates. Tunnel mode delivers the services from the network to network as well as host to network. And here the tunnel mode encapsulation builds a new IP header containing the source and destination address. The new IP header containing the source and destination address of the security endpoints. In this mode, the router IP header reflects the source and destination of the security endpoints. Which might or might not be the same as the original source and destination IP address of the data connection. Source address and destination address both are not same. So that has the IP address of the data connection. So like the way the tunnel mode operates, the tunnel mode delivers the services from network to network or host to network. So this is the way ESP encapsulating security payload provides additional security for the purpose of authentication as well as privacy or confidentiality. Purpose. So once again we revise the topic which we discussed in this session. So here we discussing what ESP, so encapsulating security payload, which is the datagram added in the IPv4 header format. So this is the basic IPv4 header format, which contains IPv4 header, TCP header, and TCP data. In that all the fields, the ESP is added inside of that IPv4 header. So immediate effect of IPv4 header, ESP header is added. The next TCP header is added, TCP data, and last ESP trailer is added, and last ESP authentication is added. So this is all which is encrypted, and from this ESP header to ESP trailer which is authenticated. So for these purposes only the ESP is added inside of the IP protocol. So here this is the ESP header format, which contains two fields, security parameters index and sequence number. And here the ESP trailer field contains fields, what padding field, the next padding length field, and the next header field, and the ESP authentication data field. And here we can observe that the ESP without authentication, and here we can observe that ESP with authentication field. So this is ESP header plus trailer contains, but authentication is not there. But here ESP header plus ESP trailer contains, along with that ESP authentication is also there. And the header fields SPI sequence number, data part contain like variable length, padding, encryption, traffic flow, and the trailer part contains padding length, next header, it would be set to 4, it would be set to original packet address and all. And here the ESP, IP security in ESP transport mode, and IP security ESP in tunnel mode. So transport mode, this is without transport mode, without ESP. and this is with ESP in transport mode. And here the ESP without tunnel mode, and this is with the ESP tunnel mode. So the main thing is what delivering the services from host to host operated in transport mode, in the host to network or network to network services operated in tunnel mode. So that is the way, that is why encapsulating security payload provides more security service rather than that IP protocol, because the ESP extra fields are added in the IP field, because ESP extra field are added in IP field. That's why the ESP provides both authentication as well as confidentiality or privacy. So this is the way, this is what we have to we are explaining in the ESP encapsulating security payload service. So thank you all.
Like, share and subscribe. Hit the bell icon for more updates.